Okay, this is 10.3, sample problem number 1. We're reviewing areas for functions that are polar, just because this is really going to help when we look at doing cylindrical integrals in the next section. Okay, we want to find the area enclosed by the polar function r equals the square root of sine theta. Well, of course, square root of sine theta has a domain where we can only use positive values for sine's output, and of course sine will be positive between 0 and pi and negative between pi and 2 pi, and so that limits our values for theta. Theta is going to have to be greater than or equal to 0 and less than or equal to pi. So that becomes our limit, and then keep in mind, in order to find area, it's in essence like we're breaking our polar graph into these little tiny triangles whose height is the radius and whose arc length is r d theta. So that means we're basically integrating r squared d theta. And in this case, that means to square this, multiply by the d theta, and then we're good to go. So that's the surface area. So the area for most polar graphs is going to be between 0 and pi, and then this is going to be r squared d theta, and that's going to be sine theta d theta. Okay, well, the integral of sine, and then the 1/2, because it's 1/2 base times height, so forgot the 1/2. So this is negative 1/2 cosine theta evaluated between 0 and pi. Cosine of pi is negative 1, so this is minus 1/2 of negative 1, and cosine of 0 is 1, so minus 1, so this is negative 2 over 2, negative 2, which is just 1. So the area inside of this graph between 0 and pi is 1.